Hello friends, I welcome you all to this session on power plant engineering. So in the previous lecture you have seen that what is a regenerative feed water heating and how it is implemented in real plants or in basic Rankine cycle, and you have also seen that how to evaluate the work and heat interactions. Now what I was saying in the last lecture at the last was that these work interactions and heat interactions cannot be evaluated until or unless you know the amount of mass flow rates from amount of these extractions, mass flow rate or the mass extracted from the turbine at different stages. So in this particular lecture, I will tell you that how to evaluate these mass interactions. Okay, so let us talk of this particular portion, and let me do what? Let me snip this. So this is the one. Okay, now for this high pressure, this feed water heater which is taking steam from high pressure side, now the amount of steam which is entering is 1 minus m1. Sorry, the feed water which is entering is 1 minus m1. The mass of extracted steam is m1 and the mass which is going out is nothing but 1. So now for this control volume, you know that first law of thermodynamics of open system is written as the amount of energy entering into the control volume plus the heat transfer will be equal to the amount of energy exiting from the control volume plus the shaft work. So as this is just mixing process, so there is no shaft involved, and at the same time we are assuming that there is no heat loss from this particular feed water heater. Also, let us say that the kinetic and potential energies for the water is neglected. Once this has been done, so we are only left with the enthalpies. So what is coming? Steam is coming with a mass flow rate m1 and the state is H2. So it is H2 plus water is coming at this point 8, okay, with a mass flow rate of 1 minus m1. This is H8 and what is leaving is 1 kilogram. So it is H9. So now if you solve this, so you will be having m1 h2 minus h8 and on the right hand side you will be having h9 minus h8. So m1 will come out as h9 minus h8 divided by h2 minus h8. So this is what the extraction for the first feed water heater. Open, obviously we were discussing only open type of feed water heater. Now let us see that how to evaluate the mass flow rate for the second feed water heater. So let us also snip it. So no, this is not coming full. So let us do again. So from here I have to do, I think from here. Okay. Now if you look here, the steam is entering at point number 3, the feed water is entering at point number 6 and it is leaving at point number 7, I think. So let us check once more. So this is point number 7. Okay. So the mass which is entering is nothing but 1 minus m1 minus m2. This is for water and it is leaving as 1 minus m1 as m2 amount will be added. So the mass will be 1 minus m1 minus m2 and exit mass will be 1 minus m1. So for this particular control volume, again, no shaft work, no heat loss from this particular feed water heater I am assuming. So whatsoever is entering, so that is at 3, so it is m2 h3. What else? At 6 also, so it is 1 minus m1 minus m2 and it is entering at 6, so it is h6 will be equal to 1 minus m1 and that is exiting at 7, so it is h7. So once this has been done, so what we can do is we can take this m2 out. So this is m2 h3 minus h6 and this 1 minus m1 will go on to the right side and that can be taken common. So that will become h7 minus h6. So the mass extracted will be 1 minus m1 H7 minus H6 divided by H3 minus H6. So this is basically the extracted mass for the second feed water heater, which can only be obtained once we know the mass extracted for the first feed water heater. And in the analysis, what we have to do is we have to keep two things in mind. That is, the state after the mixing, that means 7 here and 9 here, will be saturated liquid. So this we should understand. Now what we'll do is, in the next lecture I will show you that how to model this particular type of Rankine cycle in Excel, and then we will be doing the same thing in using CyclePad. So in this lecture, till this point only, thank you very much.